Hello, welcome to this video on A-Level Further Maths. We're looking at a vectors problem where we have the equation of a line in vector form and we have a plane equation pi in Cartesian form, and we are going to reflect the line, this line, in the plane to get a new vector equation L2. I'm going to talk you through the steps. So first of all, let's think of a general point. So the general point on this line would be as follows. 6 plus 4 lambda, 2 plus 5 lambda, negative 2 minus lambda. Now, we would then look at where that meets the plane. So L1 meets the plane when this agrees with this. So I substitute this general point into the Cartesian equation. 2 lots of 6 plus 4 lambda minus 2 lots of 2 plus 5 lambda plus 4 multiplied by negative 2 negative lambda, and that all equals 4. So I've substituted that into there. Now we just work through this and simplify it. 12 plus 8 lambda minus 2 minus 5 lambda minus 8 minus 4 lambda equals 4. We simplify this. So we've got 2 minus lambda, 8 minus 5 minus 4 gives you negative lambda equals 4. So that would give you lambda equals negative 2. So we know lambda equals negative 2 on this, with this general point when it intersects. Therefore, L1 intersects pi at, so we just can put that into there, negative 2 into there, so 6 plus negative 8 would give you negative 2, negative 2 into here, 2 plus 5 times negative 2 is negative 8, and then negative 2 take away negative 2 is 0. So that's the intersect. So we found out where the line intersects. That's going to help us. What I'm going to do now is I'm going to drop a perpendicular from this jumping on point. So this point is on L1. I'm going to reflect that point in the plane. So the vector equation from 6 to negative 2 which is perpendicular to pi would be this. R equals 6 to negative 2 plus, we use mu this time, mu 2 negative 1, 4. And I get that from here. If I say 2, negative 1, 4, that is a perpendicular direction vector to the plane. You can read it straight off the Cartesian form. That gives me a general point on that perpendicular line to the plane from this jumping on point of 6 plus 2 mu, 2 minus mu, and negative 2 plus 4 mu. So this perpendicular line, so imagine this, you've got your point there where the original line meets the plane, L1 meets the plane, we've worked that's negative 2, 8, 0. I've got this jumping on point, 6, 2, negative 2 from L1. This is L1. And I'm just dropping a perpendicular here to find a reflection of this point. And then L2 will run from there to there. So let's have a go at this then. So this general point, this perpendicular meets pi. Just move this down a bit so you can see when, and we're going to substitute in this general point back into the equation of the plane. So I've got 2 lots of 6 plus 2 mu minus 2 minus mu plus 4 lots of negative 2 plus 4 mu, and that's got to equal 4. Now if we do 2 lots of 6 minus 2 plus 4 lots of negative 2, so 12, take away 2, take away 8 will give me positive 2. Let's look at our mu's. 2 times 2 is 4 mu, 3 mu because we're adding negative, negative. And then 4 times 4 is 16. So 4, add 1, add 16. I get 21 mu equals 4. So mu will equal 2 over 21. So we know mu would equal 21. Now I'm not going to find the point on the plane. I don't need to do that. I'm going to do something much more efficient, shall we say. So the reflection of 6, 2, negative 2 in plane pi is, well, we start at 6, 2, negative 2, and then we're going to go along this line, along this general point, plus instead of going 2 over 21, I'm going to go 2 lots of 2 over 21, because 2 over 21 would take me to the plane. 2 lots of that would take me past the plane to the reflection point. So that takes me to the plane. I double that, I go past the plane to the reflection point. And then I have this point on L2. So there's L1, there's L2. And I'm going to find a jumping on point for L2. Or a point on L2. We need to multiply by 2, negative 1, 4, of course, which is my direction vector. And this doesn't give you the nicest set of numbers, but there we go. You get 134 over 21. You can stick this in your calculator, really. 38 over 21 and negative 26 over 21. When you put all this in your calculator. So, what we know is this. That point there, here, well, it's not very nice. It's 134 over 21, 38 over 21, and negative 26 over 21. Not very nice at all. But we're going to just have to deal with the dodgy numbers. Sorry about the drawing there. So, the point of this is the reflection line, L2, has points 2, negative 8, 0. That's because that's where the original line meets the plane. Now the line and its reflection will both meet the plane at the same point. That's the first point. We've got the second point on our reflection line by dropping that perpendicular here. And what was it? Yes, 134 over 21, 38 over 21, then negative 26 over 21. It's not very nice, is it? So the direction vector of L2 would be made by this. I can do 134 over 21 minus 38, over 21 minus 26 over 21. Take away negative 2, negative 8, 0. So I've got my 2 points. I go between those. That minus that will give me a direction vector along that new line. And with a bit of calculator help, you can do this. 206 over 21, negative 26 over 21. So that is my vector line. Now that happens to be perpendicular to a much nicer line. Not perpendicular, sorry. That happens to be parallel to, so imagine you just multiply by 21 and half it. What you would get would be 88, 103, negative 13. So what I've done there is I've got integers, which are nicer to have in your equation. All I've done is they're all divided by 21, so you can eliminate that, and they'd still be parallel. 176, 206, 26. I can half all of these, and it would still be parallel. That looks much nicer. So that is a direction vector on this reflection here. So L2 can equal, I'm going to use this as my jumping on point, where L2 and L1 in fact meet the plane. So that's negative 2, negative 8, 0. And then I'll just use T this time as my parameter, 88, 103, negative 13. And that, oh sorry, that was off camera, that is the line of your reflection. So in short, what you do is you've got your plane, you've got L1, you find where L1 intersects the plane. You know your reflection intersects the plane at the same time. You then, from this jumping on point given by the equation, drop a perpendicular to the plane, find what you need to do to find the reflection of that jumping on point. You've then got 2 points. You've got a point on, which is a reflection there, which is on your new line. You've got another point on your new line, which is where it intersects the plane. And you just use those two to find the equation. And job done. I hope that makes some sense at least. Thank you very much.